The next part is correlation. So before starting or looking at the different types of correlations, we should know what exactly the correlation is. So it is a bivariate analysis, which means we are only looking at the relationship between two variables and not more than two. We try to find out the strength of association between these variables. The association can be in the positive direction, which means if variable A increases, variable B increases as well. It can be in opposite direction. So if A increases, B decreases. That's why if we look at the range lasts from +1 to -1. -1 being very highly correlated but in the opposite direction. +1 means very highly correlated but in the positive direction. Okay, so that's why we have three different kinds of correlations: the Spearman correlation, the Pearson correlation, and the Kendall correlation. So these three different correlations have different formulas, and using these formulas we will be trying to find out how to find out the exact correlation between the two variables. Now again, we will be discussing in detail about all these correlation methods in our statistical lectures. But in a nutshell, if we come back to our original graph, all these correlations are generally used to find out our feature importance. So we use Pearson and Spearman when we have numerical target variable, while we use Kendall if we have categorical target variable while numerical independent variable, and also we use Kendall when we have categorical independent variable and numerical dependent variable. So these were the methods that we discussed as a score based method. But not only this, we have two more methods that we use to find out whether our features are important or not and what are the subsets. These are permutation based methods and Fischer score based method. So if we talk about permutation based method, so I'll clear the screen, and suppose again I have the columns. So I have my x1, I have my x2 till I have my xn, and it leads to my y. Now I keep the data as it is. I only select one column. Suppose I select this column. So I take, suppose, 70% of data from above, from main data set. So I keep all the other columns as it is. But in X2, I just shuffle the data. Okay. So sometimes we can take a subset and shuffle the data, or sometimes we can just randomly shuffle the data from top to bottom, taking each and every column into picture. And now what I will do is see, I will train the model. So I will train the model and check the performance. So this performance can be checked either using, and I mean, if you're talking about classification problem, then we can look at accuracy, precision, recall. If you're talking about regression problem, we can use root mean square error. Once this is done, we again restore. So now again my original data set is back. Now again I take a column randomly. So now suppose I have taken x5 and x5 is shuffled, and then again my performance is checked. So likewise all the columns are shuffled, and based on that the performance is checked. At the end, whichever column after being shuffled gives the least good result are the most not important variables, while the other columns are the important variables. So this is the permutation based approach where, as you see, I take any variable, I shuffle the value, then I check the model performance, Then I get back the original data set, take any other column and repeat the steps. Finally, I have a Fisher score based method. So if I talk about Fisher score, it is generally finding the similarity between the instances. So suppose I have some data points and I have some data points here. So first thing is this can be called as one cluster and it can be x1. This can be called as second cluster and it can be x2. So the distance between the clusters x1 and x2, which is this should be very high, while the distance between the instances present in each cluster, which is distance between these two points, all these things, it should be very low. So Fisher score tells us in one specific score, it tells us how much high is this distance and how much low is this distance. If both are perfect, Fisher score will be good. If both are not perfect, Fisher score will be bad, which means low. So that's what we talk about in Fisher score based feature importance. So again, class based similarity approach, minimum distances between the instances of same class, maximum distances between the instances of different class. So now this finishes our score based theoretical dis- uh, discussion about um, feature importance. Now let's move on to the live Python coding and let's apply all these different statistical approaches on a specific data set, which is the stroke data set, which is healthcare stroke data set that we will be using, and trying to find out what are the variables which are important and what are the variables which are not important.